We will solve one advanced problem and rolling motion. So see the problem. A hollow cone of radius r and height h and mass m, it does not have the base, rolling on a similar fixed cone with angular velocity 2 radian per second on vertical axis. If semi-vertex angle theta is equal to 30 degrees, mass of the cone is 2 kilograms and radius is 1 meter, find the kinetic energy of the rolling cone in joules and the angular momentum about its instantaneous axis of rotation. So, to solve this problem, first we need to understand about the cone. So, here the cone has base radius r and the vertical height h. This one is the cone. This cone has base radius. This, if I take this one, this passes through the center. This base radius is r and its vertical height is from this point to this point. This vertical height is h and the semi-vertex angle is theta. Then tan theta is equal to, right, the relation between r and h we will get r by h, otherwise r is equal to h tan theta or h is equal to r cot theta. This one is the relation between h and r. Same like, right, the center of mass of the cone lies at a, because it is a hollow cone, the center of mass of the cone lies at a height h by 3 from the base or 2h by 3 from the vertex. So this one is the position of center of mass. But I don't need the center of mass of this cone, but I need the center of mass of rolling cone. So over the surface, another cone of same dimensions, is rolling. So for this also, if I take the vertex angle, semi-vertex angle, this semi-vertex angle is also theta, this radius is also r, and its center of mass, is at a height h by 3 from the base center, and from the top center this distance is also equal to 2h by 3. So this one is rotating about vertical axis. This cone is rotating about vertical axis. This one is the vertical axis. About this vertical axis with angular velocity omega is equal to 2 radian per second. So from the vertical axis to the center of mass, if we find the perpendicular distance, we can find the linear velocity of the cone, center of mass of the cone. Therefore, from here draw one perpendicular line. So this angle is 90 degrees. With axis it is making an angle 90 degrees. If I suppose take these points as, this point as O, this point as A, this point as C, right? From the triangle, right angle triangle OAC, right? What can we find? We can find the value of AC as 2h by 3. 2h by 3 becomes, right? See this, 2h by 3 becomes hypotenuse. 2h by 3 into sine 2 theta. 2h by 3 into sine 2 theta. This is the distance. But angular velocity we already know as omega. Therefore, linear velocity of the center of mass. This we need to find. What is the linear velocity of center of mass? Velocity of center of mass of the cone. Right? This one I want to represent with the symbol. Velocity of center of mass is equal to, we have an expression. What is the expression is AC into omega, perpendicular distance into angular velocity. But AC is equal to, what is the value of AC? AC is equal to 2h by 3 into sine 2 theta into omega. This one is velocity of the center of mass. So this, by using this velocity of center of mass, we can find the angular velocity on instantaneous axis of rotation. Where is the instantaneous axis of rotation? Right? So the pole is rotating on the slanting side of the fixed pole. That's why the slanting side acts as instantaneous axis of rotation. This is instantaneous axis of rotation. So instantaneous axis of rotation. Slanting side acts as instantaneous axis of rotation. I want to find angular velocity on instantaneous axis of rotation as omega dash. This value I want to find. This value as omega dash. So how to find this value? For finding of this value, again we need to find the perpendicular distance from axis of rotation, instantaneous axis of rotation to center of mass. So instantaneous axis of rotation to center of mass, the distance is, this one is the perpendicular distance, here 90 degrees. If I take this point as D, ODC, triangle ODC. If I take this triangle, right, DC is equal to OC into sin theta. This one is equal to 2h by 3 sin theta. Then angular velocity on instantaneous axis. Angular velocity on instantaneous axis. This I want to find. Instantaneous axis. This one, if we take like omega dash is equal to velocity of center of mass divided by perpendicular distance. This is dc. Then this is, right, omega into 2h by 3 sin theta, sin 2 theta divided by 2h by 3 sin theta. So anyhow 2h by 3 will cancel out. If 2h by 3 cancelled out, what is remain? Omega dash is equal to omega dash. This one is equal to omega dash is equal to omega into sin 2 theta divided by sin theta. Otherwise, it is 2 omega into cos theta. This value is remaining, omega dash. So because we know the omega dash, it is easy for us now to find the kinetic energy and angular momentum. So for finding the kinetic energy and angular momentum, we need moment of inertia of the rolling cone. So what is the moment of inertia of rolling cone on its slanting side? This value we know already. So omega dash, we found the omega dash, angular velocity about the instantaneous axis of rotation as 2 omega into cos theta. This we found. And we know moment of inertia on the slanting side of the cone is equal to 13 by 8 mr cube divided by square root of r square plus h square. This we know. Mr cube by, right, square root of r square plus h square. This value we know. Therefore, right, from this, if h is equal to r cot theta, if I substitute this value, right, this value becomes 13 by 8 mr cube divided by square root of r square plus h is equal to r cot theta, r square cot square theta. So r you can take common, then it is 13 by 8 mr square divided by 1 plus cot square theta square root of 1 plus cot square theta is cosecant square theta. Square root of if I take, I will get cosecant theta. Otherwise this I can also write like 13 by 8 mr square sin theta. Right? So kinetic energy is half I omega dash whole square. Substituting the values, I is 13 by 8 mr square sin theta and omega dash is equal to 2 omega cos theta whole square. If we write these values, what we get? We will get 13 by 16 m r square omega square into 4 sin theta cos square theta. Cos square theta. In this one, if we write the values, m is equal to 2 kilograms, r is equal to 1 meter, omega is equal to 2 radian per second, and theta is equal to 30 degrees. Then we will get 13 by 16 into m, 2 kilograms, r 1, omega is equal to 2 square into 4 into sin 30 1 by 2. Cos 30 is root 3 by 2, but cos square 30 is root 3 by 4, not root 3 by 2. So in this one, the terms cancels, 4 and 4 cancel, this 2 and 2 cancel, then it is 39 into 4 divided by 16 is equal to 39 divided by 4 joules. This is the kinetic energy of the rolling cone. Angular momentum L is equal to I into omega dash. Angular momentum L is equal to I omega dash. Therefore, the moment of inertia is 13 by 8 mr square sin theta into omega dash. Omega dash is equal to 2 omega cos theta. This is equal to 13 by 8 mr square into sin 2 theta. Sin 2 theta. Again substituting the values, m is equal to 2 kilograms, r is equal to 1 meter, and theta is equal to 30 degrees. Then this one becomes 13 by 8 into m, 2 kilograms, and r is 1, sin 60. Sin 60 is root 3 by 2, and omega. Omega is given as 2 radians per second. So L is equal to 13 by 8 mr square sin 2 theta omega. So 13 by 8 into 2 into sin 2 theta, sin 60. Sin 60 is root 3 by 2. If I take these values, what will I get? This cancels here 4 times. Then I will get 13 root 3 divided by 4 kilogram meter square per second. This one is the right? The angular momentum of the cone about the instantaneous axis.